right, we are in the home stretch. We have about 2 more properties to look at. I say about because there are technically more, but I'm going to spare you guys. Okay, so we're looking at quotients with the same exponents, but this time different bases. So if you have something like this, you have a number a raised to the nth power divided by a number b raised to the nth power. Notice how my exponents are the same. I can rewrite this as a fraction a over b, all raised to the nth power. So I like this rule because it allows us to rewrite fractions, right, as multiplication problems, I guess. Let's take a look. So if I have let's see, what numbers do I want to use? Let's do 4/3. 4 to the third power divided by 2 to the third power. Notice how my exponents are the same. So all I'm going to do is I'm going to take the quotient of my 2 bases, 4 divided by 2, and then raise it to the third power. So 4 divided by 2 is 2. We raise 2 to the third power, which equals 8. And there we go. Let's take a look at an example where my numerator is smaller than my denominator. Let's keep it simple. Let's go with like 1 squared over 3 squared, or 1 squared divided by 3 squared. We can rewrite it as 1 divided by 3, right? Dividing by bases, and then raising that to the second power. And then, of course, I know that this is just 1/3 times 1/3, and that is equal to 1/9. That is my final answer. Now, let's take a look at some variable examples. So let's do x to the third power divided by y to the third power. Okay. Notice how my exponents are the same. So I can just rewrite it as x divided by y, right? The division of my 2 bases raised to the third power. However, with variables, I feel like our answer here is a little bit more confusing than our original problem. Let's do m to the 4th power. Oops. Let's do like m divided by n, and this is raised to the 4th power. What's nice is you can translate this back, so that way each variable or each base now it can get its exponent. So I can rewrite this as m to the 4th divided by n to the 4th. So you guys see how you can move forward and backward, right? You can change one form into another. That's what's so great about these exponent rules, is it allows you some wiggle room when you're working with the math, okay? So in my opinion, I feel like you're going to be using this more when you're working with variables rather than this, because this right here is a little harder to work with than the one on the right. So I don't know. That's just my opinion. You might feel differently, but that's okay. All right, so there you have quotients with the same exponents but different bases.